We have two more examples to find a differential operator. Let's look at number 4. You've got 3 terms. Are they all the same pattern? The answer is no. They're all 3 different patterns. This will be case 1. Minus sine x, you don't have to worry about the minus. The sine x is pattern 3, operator 3. But the alpha here is 1. 10 cosine 5x, you do not have to worry about the 10, is also case 3, but your alpha is different. It's 5. So when you've got different patterns, what you do is you find a differential operator for each one and you multiply them together. So let's look at 8x. What will annihilate 8x? That's going to be a d squared because it's n is 1 more than your highest exponent on your variable, times, this is case 3. I've written the formula in the bottom right hand corner. That will be d squared minus 2 times 0. I'm sorry, that's beta's 1. Beta's 1 and alpha is 0. Alpha is 0 because you've got e to the 0x assumed in there. All right, so I've got d squared minus 2 alpha being 0, d, plus alpha squared plus beta squared. And it would all be raised to the first power because you do not have a factor of x. Now let's figure out what annihilates 10 cosine 5x. Alpha is 0 and beta is 5. So that's going to be d squared minus 2 alpha d plus alpha squared plus beta squared, all raised to the first power because you do not have a factor of x in there. So simplify. That will be d squared times d squared plus 1 times, simplify this last one, that's d squared plus 25. That's what annihilates number 4. All right, number 5. Oh, I wrote down the same problem. Hold on a second. That will be, come on, eraser. Number 5 is e to the negative x sine x, that's case 3, minus e to the 2x cosine x, that's also case 3. But you're going to have to do 2 different ones because your beta is the same in both of them, it's 1, but your alpha is different. Here your alpha is negative 1, your beta is 1. Here your alpha is 2 and your beta is 1. So you're going to have to figure out those 2 and then multiply them together. Let's look at e to the negative x sine x. That's going to be d squared minus 2 times alpha d plus alpha squared, negative 1 squared plus 1 squared, raised to the first power, times, look at e to the 2x cosine 5x. That's d squared minus 2 times 2d plus alpha squared plus beta squared. Now let's simplify those. That is, oops, come on, pen. That's going to be d squared plus 2d plus 2 times, that's the first differential operator for this. And now simplify the last one. That will be d squared minus 4d plus 2 squared plus 1 squared, which will be 5. And that's the differential operator for e to the 2x cosine x.